Alright, hello and welcome to this episode of T-Tech. This is part 2 of 3 in our Linux Network Firewall series. So in this part, we've already found our hardware. We've already done a stock install of Debian Linux in this case. Alright? So the first thing you want to do is make sure you found your hardware that is, of course, compatible and has enough RAM and CPU and everything. In addition, don't forget, you gotta find 2 NICs. You can, if you have a desktop, you can use the built-in NIC, and then you can find a PCI Express or a PCI if it's like a little bit older, and you can plug that in there and then have 2 interfaces. So as long as we've done that, though, we can get started. And what we're going to do is log in as a user, do whatever you created during the installation, and we want to become root with the su command. And now, the first thing to do is back up our interface file, because in order to make a LAN and WAN interface, we have to assign those addresses. So we want to back up this file here to something ending in .back, and don't be afraid to do this if once you get it running you're messing around with it. Always make a backup of any config file on your system before you change something and you're not sure. Coming from experience, I've broken a lot of things that way, but that's besides the point. Alright, now we have a backup. Let's go into... Oh, I'm sorry, I forgot to show you. Type IP space adder here, or ifconfig, but IP adder is a more modern way. And what we want to do is, in my case, ENPS0 number 2 there is my LAN interface. That's where that IP address will be. And number 3 there is ENP0S8. That's my WAN, okay? So that's the interface that's going into your modem. So we're going to go ahead, and now we can go into this file. And if your provider just uses DHCP, that's Dynamic Host Configuration Protocol, you can leave the WAN interface how it is. On the other hand, we used static in our diagram, so we're going to put, after init there, we're going to put static, and then I'm going to put address 192.168.0.25. This next thing after the slash is called the CIDR, the classless interdomain routing. This just means that we have octets in this IPv4 address. What the 24 represents is the bits. So an entire address is 32 bits. And what we're saying with this is 24 bits of this one address can't change. They're part of the network. So that's the subnet. So this means, because each of these sections are 8 bits, that the 192.168.0 is the 20 up to 24. Those are all 24 when you put them together. 8, 16, 24. Alright? So when you put all those together, though, those are the ones you cannot change, and that's how the router knows. After that, though, we need a gateway, and it's 192.168.0.2 in my case. Always remember this when you're setting this stuff up. You want to have it must be the case that the gateway is on the same network. So if any of these sections were different, you're not going to be able to route to the gateway, because you actually have to use things like ARP or NDP if you're using IPv6. So you have to have that on the same subnet. Your gateway is on the same subnet as your WAN address. Always remember that. So after that, though, let's set up the LAN address. And we need to say allow-hot plug, like this, and then ENP0S3. And now we have to say iface ENP0S3 init static. We're going to say address 192.168.1.1, use that /24, but on a LAN interface, you don't put a gateway. Alright? Don't put a gateway on your LAN. Now we're gonna hit colon and type WQ, and we're gonna write and save the file. Now you want to do if down enp0s3. Whoops. Make sure it's /sben/if down enp0s3. And then you want to do sben if up enp0s3. So now if we do ipadder now, look at number 2, which was our LAN, and now it's got the address and mask we put in there. And if you look at the WAN, which is number 3 still, it has an address, the dynamic address. The reason that is we have to bring that interface down. So just do if down enp0s8. And then we want to say that same if up command. And now if we check, now we have that address. Now on your Firewall 2, we have to configure DNS servers. So to do that, you want to go into etc resolve conf. And what we're going to do here is put name server space. I'm going to put external ones on the internet. I'm going to put 4.2.2.2 and 4.2.2.1. Okay, and that will work being external. Again, let's save that file. So now we have our LAN and WAN interfaces configured. At this point, it's a good idea to do a ping. So let's do a ping and make sure you get a reply from the firewall itself. Now we're going to go into setting up our IP routing. All we have to do is edit this file, etc/sysctl.conf. And in Linux, they've made it very easy. All you have to do is uncomment this one line, and that turns on the forwarding of IPv4 packets. And that just means it will forward a packet that's not destined for itself. From here, we need to configure the firewall. So let's go into etc initd. All right, so we have to make a program that has the rules in it and has them load for us. And we're going to make a shell program for this. So in our boot directory, we're going to make a file called fw. And we're going to start by having an interpreter line, bin bash. And now, if you're familiar with programming, and even if you're not, that's fine, we're going to make some variables, and they're just like an envelope. It holds information. We're going to say LAN, and this will be our LAN interface name, like that. Make sure it's in quotes. And now we're going to say WAN. We're also going to say LAN net. This will be our network for our LAN. So that'll be 10/24. And then our WAN will be 192.168.0.0/24. So after this, let's put in some comments for ourselves. So flush everything on, well, the firewall is called netfilter, so we'll put that in the comment. But essentially, we want to reset ourselves to a default state. We're using the command iptables-F, iptables-tnat-f, and iptables-x, capital X. And that means the chains and tables in netfilter. So we need default policies next. And what we're going to specify is iptables-P input drop, iptables-P forward drop, and iptables-P output accept. Now, the chains here, netfilter has tables and they have chains. A table contains one or more chains. Okay? So the input chain is a part of the filter table. And this input chain processes packets when they're destined for this machine. So if you start Firefox, just for instance, you don't run Firefox on your firewall, but if you start that, this data that goes up and down through the network gets processed through the input chain. So what it means is when a program is listening on a socket to receive data from the network, the data goes through the input chain. So it's for programs on this machine is what that deals with. And what the drop is the policy, if it doesn't match a rule in the chain. So it's like a catch-all, okay? Forward is not for applications on this firewall itself. It's actually for routing the packets. These are the rules that decide if a packet can be routed a certain way or can't be routed. So it's not destined for this machine. It's destined for networks this machine is attached to. So our LAN and WAN, that's the example. That's what it's for. So we're going to write rules that control the LAN access to the WAN and vice versa. So everything we don't put in that chain as a rule is just going to be dropped. So it's very secure for us. Now, output, though, is for your applications when they start a connection from your machine. So input is like if data is coming from Firefox into Firefox, but you didn't start a connection. Output is like when you actually go to Google on purpose and it sends the data down first. That is okay, we're assuming. So we're going to say accept, and we actually don't have to write any rules for that chain. All right, so from here, let's go ahead and do firewall destined traffic policy. And we want to add to the end, so append any traffic coming in on the loopback interface. And we want to jump to the target of accept. And also we want to append that any traffic that has a state, so we're using a module with M there, of related, comma, and then established. We want to accept that traffic. We want to also input. We want to accept ICMP traffic to allow pings and stuff to happen. We want that to come in on our LAN interface. And accept. And then IP tables A. We want to accept some traffic for a DHCP server that we're going to set up a little bit later. All right, that's our input first. And then next, we're going to focus on our forward chain. All right, so now we need to go ahead and make our forward policy. Now, our forward policy is going to be for our LAN. So this is our LAN to WAN traffic policy, all right? So we're going to say IP tables, and now we're going to append to the forward chain. And then we want to say that the traffic has to be coming in, with lowercase I, and we're going to utilize our variable with a $sign to tell our program it's a variable. Do LAN, and then -s for the layer 3 source address in the IP header. Now, in this case, we're going to use a $sign LAN net. Now, that also has to be routed out of the WAN interface like this. And then once we do that, we want to accept that traffic. Now, we also want to go ahead and have it so it matches any existing traffic. So with the module state and then the -- state related, comma, established, like that, and then -j, accept. Now, the last thing we need here is that we need our NAT policy. So this is our LAN to WAN NAT policy. This is not port forwarding. This is the source NAT we spoke about. So this is IP tables. We need to work on a different table this time called the NAT table. The other ones were on the filter table. From there, though, we want to append the rule to the post routing chain. This is after the routing decision has been made by the networking stack. So if you want to do port forwards for destination NAT, you have to make the decision before you route the packet, so you have to put it in the pre-routing chain for a port forward. So from here, though, we want to make sure that it is coming from the LAN net and that it is going out of the WAN interface. And if it is, we want to jump to the target masquerade. All right? Now, one important thing for any of the rule targets, there's things like log and other stuff, but why I use drop as my policy is because it doesn't send any replies. So it doesn't send ICMP port unreachable messages or any timeouts or any indication that the connection failed or was being blocked. You can also set this to reject. I don't recommend it. It's good because it lets the application, like Firefox for instance, time out immediately, but it's bad because it sends back information we can use like with Nmap to gather information about our firewall if someone is in reconnaissance of a cyber attack. So you want to set that to drop, in my opinion. So from there, we should be able to save this file, all right, just like before. We want to say change mod, making it so the owner has an executable permission. Now, let's test the file we made. You want to do iptables-nv capital L, make sure everything loaded, and it did here. And then if we check the NAT table, nv capital L, we're all good on that. Now, we have to create we have to make it so this can boot up. So you want to go into, we're on run level 5, we're going to go in etc rc5.d, and then we're going to make a symlink. So ln-s, we're going to link the file we just made to S01 firewalls. We need to lastly do update rc.d, and then the name of the file we created, fw, the program, and say defaults. This hooks it all into the boot system. So when we're booting up, it goes through that boot directory for all those programs and starts them. So we have our interfaces, our routing, our firewall done. Now we have to install the DHCP server, okay? This is needed because this hands out addressing information and DNS server information. This only works for IPv4 in this configuration. After it finishes, don't panic. It tries to start, but we haven't told it what to do yet. So we want to go to etc default ISC DHCP server, and you want to uncomment the variable DHCPD v4_conf. You want to uncomment the version 4 PID file, and under interfaces v4 in the quotes, put your LAN interface, so EMP0S3. And then let's save that. And now the config file for DHCP is in etc DHCP dhcpd.conf. We are going to back that up just like before with our interfaces file. Want to back that up just in case. And let's remove the original. And let's make a new version real quick. We're going to say option domain name. This is your local domain name. It can be whatever you want. It doesn't actually have to resolve on the internet unless you've set that up. Now we're going to do option domain name. Whoops. Domain name servers. And then let's say 4.2.2.1, comma, space 4.2.2.2. And these are external ones that our clients will use. They can be internal as well. We're going to say subnet 192.168.1.0. You want this to be your LAN subnet, and that's what's called the network ID part of it, the beginning of it, in other words. And then we want a net mask. This is a 24-bit subnet mask. That's what we need, because otherwise the clients won't know what network they're on correctly. Then we're going to open a curly brace, enter down, and tab in. So in this subnet, what we want to do is hand out specific addresses. So we want to hand out 100 through 1200, and with a semicolon. And then we want to say what our default gateway is, option routers. So remember with ARP, this is what it tells the clients to send. It says send to me if the destination isn't on your network. And this is what that option is for. This range, the entire subnet range is 1 through 254 in our case. So just because 100 and 200 are here, you can still use 1 through 99 at the end here, and up to 254. The difference is that range will be dynamically assigned, so a lease will be created for it. All right, let's do DHCPD-T to test everything, and this is why we test. So there's an error, and under domain name servers, make sure that that is a comma and not a period. And there we go. That means it's working for us. All right, so at this point, we're going to reboot, and then we're going to verify that everything is working. So I'll see you there. So just reboot, and I'll see you in a second.